welcome back to Cracking the Cryptic, and a fascinating looking puzzle today by a debutante, so we'll look forward to that. Now I do want to mention Patreon. We've got already on Patreon the taster pack, the bonus puzzles for Panthera and the Asylum's Paint by Numbers special, which will be our November monthly reward. Lots of Japanese sums puzzles. Now I was told, and I hadn't realised, that the bonus puzzles were rejected as being too hard for the pack. So if you can do any of them, you can do the whole pack. That's clear. So it's quite a big pack, but there's a lot of puzzles, but there are a lot of very straightforward ones. So do give it a go if you're a Patreon. And that will be coming out on the 1st. As I say, that bonus pack's available. So on Patreon is my solve or my explanation of the finish of a really interesting listener crossword by Enigmatist that came out a few weeks ago. I think that deserves wider recognition. It's amazing. So do check out our Patreon for that. Under the video, there are links also to our Discord server, where there is so much chat, help, and advice for everything connected with us going on. There are links to all of our apps, and we are thinking about what to do next in the apps, and we know that there's an update due on one of them, certainly, so we are working on that as well. Now, apart from the apps, we've got obviously Sven's Sudoku pad available as well, so it's all there in the links under the video. The first one, though, is to this puzzle, the Ring of Cupidity. Now, if I read the email correctly, Palando's wife sent it in to us as a recommendation, so we are going to have a look at this. Apparently very approachable, so good news there. If you like having a go at our puzzles, you're sometimes a bit afraid to, this is the one. Give it a shot. Not that many rules. So normal Sudoku rules apply. We have arrows. Digits along an arrow add up to the number in the attached circle. Now I've made most of the arrows green to distinguish them from the one big one, which is grey. So all of those digits add up to the number in this pill, which is 42. So that's a start anyway. They're the only given digits we get, but they could be very useful for this arrow. Also, there are quadruple circles. So these 4 digits have to contain 1, 4, 6, and 9. These are 2, 5, 8, and 9. These are 4, 5, 7, 8. These are 3, 5, 6, and 7 in some order, not necessarily in the order given, although that would have worked for that too. I obviously made this one transparent because it helps to be able to see the line underneath it. So that's what we have going on. Do give it a try, as I say. Nice and approachable. I'm going to start now. Let's get cracking. Yeah, okay. It's not specifically mentioned in the rules, but I did say that this number adds up to the number in the pill being 42. You have to read that left to right, and that's the bit that's not mentioned. Now, I had a thought while I was talking. Could it add up to 24? And the interesting thing about this ring, which you may know by another name other than the Ring of Cupidity, which is the title of the puzzle, is that it can't add up to 24 because these 5 have to be a minimum of 1 to 5 to be different digits. That's 15. Same again here. That's 30. And this will do it. This will tell us we've still got these cells to add in, and they've got to add up to at most 12. And that is also the least they can be. So they must be sets of 1, 2, and 3. As always, when I've been talking for 4 minutes, my throat's asking me to cough, so I apologise for that. Right, so we've got these 1, 2, 3 sets. Now exactly the same applies if you consider the 2 verticals here on this ring. They could each be 1 to 5, making 15. So the blue highlighted area now would be 30. And again, these cells will have to add to 12. So they must be a 1, 2, 3 set as well. So we've got this whole stuff going on. I don't think we're going to need the Fistemafel ring in this puzzle, although you might be screaming that at me already. What we do need to put into it now are 4 and 5 in each row or column. So we need 2 4s and 2 5s. We can tell from that one which way round they go. Actually, I can see we could tell from the quadruple circles where the 4s and 5s are in that ring. And we've got a real start. This now does add up to 42 straight away. however we divide up the 1, 2 and 3. So we've got 8 and 9 left on this circle. 1, 6 and 9 here, but 1 cannot be here or here because there is a 1 in those 3 cells and there is a 1 in those 3 cells. So we can put the 1 in and we get a 6, 9 pair. Yep, down here, look, there's a 3 in one of those cells, there's a 3 in one of those. So the 3 down here can't be in those positions and we can put it in there. This doesn't have a 1, 2 or 3. Oh, but it does have a 5. So 5 there and 5 there rules out that cell and that cell. And we can put 5 in. And a 7, 8 pair. So, yeah, we've got this little ring of 6, 7, 8, 9 pairs that we can't resolve yet, I think. Okay, let's have a look at this arrow. This is in a box with 1, 4, 6 and 9 already gone. So it's made up of 2, 3, 5, 7 and 8. Now this cell can't be a 2, 3 or a 5 given those digits. So that is 7 or 8. And then I think this has to be either 2, 5 or 3, 5. It must be a 5 used. This one can't be 2 because of that. And that is definitely true. This one can't be 4, 2, 5, 8 or 9. They're already used up in the box. It also can't be 1 or 3. So that is 6 or 7. Forgive the typo. Oh, this in this column, we've used up 1, 2, 3, 4, 5. 6, 9 have been used in the box. So this has to be 7 or 8. There's now a 7, 8 pair as well as a 6, 9 pair in the box. This is going to have to be 2 or 5, and that means 3 is on this arrow. So it must be a 3, 5 arrow adding up to 8. That makes that one a 7. Look, that's fixing the 6, 7 on this circle, and I think that's going to go around the grid and fix all the circles. 8, 7, yes, 8, 9, 6, 9, and all of our circle clues are done. This has become a 7 now. Ooh, we've got 1, 3 and 6. Oh no, 1 and 3 there, so that's a 6 actually. So this is 7 or 9. No, it's not 7, it's 9. And we've finished box 1. The 3 makes that a 5. We get a 2 there. We've finished box 3. This we can finish off with a column. Is an 8. Oh, yeah, we've got 6 and 9 to put in at the end of this row. And this one can't be a 6 because there's already a 6 in the box. Oh, we can finish this column. Then we've got 1, 2 and 3. They can all go in. I think we're going to suddenly finish all the corner boxes. Yes, we are. So they're all completely done. Now up here we have, 4 and 8 to place. But this can't be a 4 because this one can't be a 1 or a 3. A 4 would always be made up of 1 and 3 on the arrow, but that cell can't be those. So that's an 8. Which doesn't finish off the arrow. We have 5, 7 or 6, and there's still 3 combos that work with the 8. So let's have a look here. 4, 6 or 7, 5, 8 or 9. Well, this can't be 8 if that's no bigger than 7. So that is a 5. This is 6 or 7. That's 1 or 2. Oh, look, you can't have a 9 on a 2 cell arrow. So that's an 8. And in fact, that must be 8 plus 1 equals 9. That makes this a 2. We've finished this arrow. We've nearly finished box 6, but not quite. That can't be 2. That can't be 3. That can't be 1. 4, 6, 7, triple there. 5, 8, 9. Oh no, we can write those in. 5, 8, 9. Thanks to these positioned digits now. And that can't be 7. That doesn't get very far. Right. Down here, 4, 8 and 9. Yes, we can write those in as well, thanks to these digits. So we get a 4 there, 9, 8 on the circle. 8 minus 1, 2, and 3 is 5, 6, and 7, but this can't be 5 or 7. Bingo. 6 there, 2 there. I think we're nearly done now. This is brilliant. 5, 6, and 7 to go in there, which I can't resolve at all. And in fact, same set as there. Right, let's have a look along here. 6. Yes, that fixes this as a 4. Now we've got, well, 1, 3, and 8, but that clearly can't be 1 or 3 on this arrow. So that's the 8. This set has to have a 1 on it because of the arrow being 8. You cannot make up a three different cells with different numbers and not use a 1. So that's using the 1. That becomes a 3. 3 there. 1, 2, 3. That does that whole triple. This has become a 2 because of 3 and 1 being placed there. That is now a 6. Can't do those two. Got 5. This can't be 6. That's 5 or 7. Right, the 8 arrow though doesn't include a 4. So it's 1, 2, 5, and that is going to finish off any remaining question marks over the rest. So there we go. That really is approachable. Very neatly done. You can see how the numbers kind of cycled around the grid and came back. And there we go. So not too difficult. I do hope you had a go at that. The Ring of Cupidity. Now, Cupid is a love god, but I think cupidity is used to mean greed or envy or haste, maybe. Well, I mean, I could easily have run into a problem with haste because I know I probably attacked these too fast as though they're gas puzzles. And I will be back with some gas tomorrow, I think. So hope you didn't, well, you can say if you found that too easy, but I think it's not all that easy. It's just very neatly done. It does also prove the other name for this ring, other than the Ring of Cupidity, is of course the Fistemafel ring. And Fistemafel's theorem says that the exact numbers that appear in those cells must also appear in this set of 4 cells around the outside corners. And I mean, we can see that they do. We've got 4 sets of 1, 2, 3 in each of those, and 2 4s and 2 5s. So it was exactly the same as this ring, but we didn't need the theorem to solve the puzzle. Just another interesting demonstration of it perhaps there. Anyway, thank you very much for watching as always, and certainly we hope to see you again soon on Cracking the Cryptic. Bye for now.